Welcome, students. Now that we've learned how to do arithmetic with integers, now we're going to look at arithmetic with decimals. And we're going to start with addition and subtraction. So let's take a look at an addition problem. 3.5 plus 2.74. Now, when we're adding decimals, we need to stack them on top of each other, just like when we were adding whole numbers. But the important thing here is to line up the decimals. So I'm going to write 3.5 and then plus 2.74, making sure that those decimal points are lined up properly. Now what I'm going to do, we don't actually need to put anything here, but it's nice to put a 0 as a placeholder. 3.5 is the same as 3.50. So there's really no difference here, but it makes things look a lot nicer. And when we get into subtraction, we'll see a situation where we definitely need that. So let's go through and add. We've got 0 plus 4 is 4. 5 plus 7 is 12. So we put the 2 down there and carry the 1. 1 plus 3 plus 2 is 6. And then in the final answer, the decimal point needs to go in the same place that it goes in the parts above. So it's got to all be lined up. So our answer here is going to be 6.24. So when we're adding decimal numbers, all we need to make sure that we're doing special is lining up the decimal points in the things that we're adding, and then keeping the decimal point in the same position in the answer. That's it. Let's look at a subtraction problem. Let's take a look at 3.5 minus 2.74. With subtraction, just like addition, we need to make sure that we're lining up the decimal points. With subtraction, remember, the larger number has to go on top, so it's going to be 3.5 minus 2.74. And this is where we get in trouble if we don't put in that placeholder. Sometimes students forget to put in the placeholder and they just say, oh, all I have is 4, I need to bring the 4 down. But that's not actually how it works. If we put in this placeholder, then we see we can't take 0 minus 4, and we recognize that we need to borrow from the 5. So the 5 becomes a 4, making that 0 a 10. 10 minus 4 gives us 6. And we're going to have to borrow again because we can't take 7 away from 4. So this 3 is going to become a 2. The 4 becomes a 14. And then we can continue. 14 minus 7 is 7. 2 minus 2 is 0. And the decimal point goes right where it is in the other numbers. So we end up with 0.76. And it's going to be positive 0.76 because the larger number was positive. So we know our answer will be positive. If, for example, the problem had been 2.74 minus 3.5, we would set things up in the same way. It's a subtraction. The larger number goes on top. We would put in that 0 as a placeholder. We would get the same thing, but in the end, we would have to recognize that the larger number was negative. It's being subtracted there. So our final answer is going to have to be negative, and it'll be negative 0.76. So everything with adding and subtracting decimals is the same as it was with integers, with the exception that we have to make sure we're lining up those decimal points, and occasionally we're going to have to put in a 0 as a placeholder. But that's it. Otherwise, the rules are going to be the same. Let's take a look now at a multiplication problem. This will be a little bit more involved. And the example we're going to start with is 1.25 times 2.3. When we're multiplying decimals, we don't actually line up the decimal points when we're setting up the problem. We ignore the decimal points and line everything up as though they were whole numbers. So we line up the rightmost digits here. When we perform the multiplication, we're going to ignore the decimal points until the very last step. So let's do this like we normally would. We'll start with the 3. 3 times 5 gives us 15. Carry the 1. 3 times 2 gives us 6, plus 1 is 7. And then 3 times 1 is 3. Then we bring down a 0 and we move over to that 2. 2 times 5 is 10. We carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. And when we add up 5, 7, 8, 2, we've got 2875. Now the answer isn't 2,875. That would be a little absurd. The way that we figure out where the decimal point goes in the answer requires looking at where the decimal points are in the problem. In this problem, there are 3 digits to the right of the decimal points. There's 2 digits in the first number and 1 in the second number. And because there's 3 in total, what we need to do is we need to put the decimal point in the answer so that there are 3 digits to the right of it. So in this case, we're going to have 2.875. And that is our answer. Let's do one more, and then we'll move on to division. Let's take a look at negative 32 times 1.8. We know when we're multiplying, a negative times a positive is a negative, so the final answer is going to be negative. And we can ignore that negative sign when we set everything up. We've got 32 times 1.8. We can multiply. We'll start with this 8. 8 times 2 is 16. Carry the 1. 8 times 3 is 24, plus 1 is 25. Then we put in our 0 as a placeholder and move over to the 1. 1 times 2 is 2. 1 times 3 is 3. When we add, we've got 6, 7, 5. Now in the original problem, there is 1 digit to the right of a decimal point. So in the answer, we need to put the decimal point in the position so that there is 1 digit to its right. We get 57.6, and because we said the final answer would be negative, it's going to be negative 57.6. And that is our final answer. We'll look at division in the next video.